Alright, let's look at the ODE Euler equation, right? Number 21. Alright, let's find a general solution to the equation, which is the Euler equation. X squared y double prime minus 4x y prime plus 6y equals 0. Alright, so we're going to use this substitution. I'm going to let v be natural log of x. Alright, then let's look at the first derivative. Right, so actually before that I'm going to take the derivative of this. Alright, so we get the dv over dx is going to be 1 over x. Alright, so let's look at the derivative. So y prime is going to be, alright, this is dy over dx, right? But I'm going to rewrite it as dy over dv times dv over dx, right? Then you can see that here we know that dv over dx is 1 over x, so we plug it in here, right? So we get this expression. This is going to be, I'm going to put the 1 over x first, right? Then you have a dy over dv, right? So we have expression for y prime, right? So let's find the y double prime, right? So y double prime would be, we would have to take the derivative of y prime, which is 1 over x dy over dv, right? Then let's use the product rule to take the derivative, right? So derivative of the first guy, 1 over x is negative 1 over x squared. Then multiply by dy over dv, right? Plus, we have 1 over x times derivative of dy over dv with respect to x. So what we can do is we can go ahead and take the derivative with respect to v first, then multiply by dv over dx. Alright, but again, we know that this guy right here is 1 over x. So what we can do is, looks like both terms have 1 over x squared, 1 over x squared. So I'm going to pull out the 1 over x squared. Right? I'm going to write the second term. So x squared is pulled out. So you have a second derivative y with respect to v, right, minus dy over dv. Right? So we have a couple of expressions. So here is y prime. Right? Here is y double prime. Right? So what we can do is a y prime. So I'm going to just plug this guy right in here. And plug this guy right in there. Right? So this is what you get. So after the substitution, right? So you have x squared, right? But the y double prime is 1 over x squared. So you see that something nice is happening here. And then second derivative y with respect to v minus dy over dv. All right? Then you have minus 4x. Alright, so y prime is 1 over x, right? Something nice happening again. And dy over dv. Alright, then you have plus. You have a 6y, so you don't have to change this one, is equal to 0. Alright, then we can cancel here x squared and x squared cancel out. Here's x and x cancel out. So what you get is going to be, right, let's collect the second derivative. So second derivative is just sitting right here. All right, so we get second derivative of y with respect to v. Right, then first derivative, so we have to collect those guys. So it looks like we have, there is 1 right here. All right, negative dy over dv. And here we have negative 4 dy over dv. All right, which means that it's going to be negative 5 dy over dv. And plus 6y is equal to 0. All right. All right. So since we have a constant coefficient, we can do the characteristic equation, which is going to be r squared minus 5r plus 6 equals 0. Then we can factor this out, right? So here, so we have r minus 2 and r minus 3 is equal to 0, and which gives us r equals 2 and 3. All right, so for this differential equation, we have a general solution y, so this gives us y. This is actually in terms of v, so y of v is equal to, all right, c times e to the, right, 2v, well, I'll call it c1, and then c2 times e to the 3v. All right. But we don't want to use v because v is a substitution we came up with. So we have to write the general solution in terms of x. So we just have to put that back in. So remember that the v is natural log of x. So therefore, we have y of x is going to be c1 e to the, right, so it's going to be 2 times natural log of x, and plus c2 times e to the 3 times natural log of x. All right, so we can do a little bit of simplification. So 2 can be placed as a power here. 3 can be placed as a power here. And also, e and the natural log, exponential function and natural log cancel out because they are inverses of each other. So therefore, we have this solution. Y of x is equal to c1 times x squared plus c2 times x cubed. All right, so this is the general solution of the given Euler equation. All right, that's it. I hope that this was clear.